this is a hard question. And I think in this question, I started by saying, well, let me see if, for example, f of 7 is 1. We're told that this is true for every prime number. And if I replace x with 7 and y with 1, I just wanted to see what happens. So you'll get this f of 1, f of 7 plus f of 1. And we know that this is 1. That one just is f of 1 because that's 1 plus 1 plus f of 1. And that tells me that f of 1 is 0. So that was kind of the first observation. But then I know that f of 2 is 1, f of 5 is 1. And the question is, how do we get to this? And the key insight was that to think of in terms of the prime factorization. So 16 is 2 to the 4, and then we have 10 to the 4. So I can write this as 2 to the 4 times 5 to the 4, or 2 to the 8 times 5 to the 4. So the question was, can I figure out f of 2 to the 8? Because if I apply this and call this x and y, then I know this would be f of 2 to the power 8, f of 5 to the 4, plus f of 2 to the 8 plus f of 5 to the 4. So can I get to f of 2 to the 8? Because whatever process I use for that, it will then apply for that as well. So the idea was to start with what I had done here, for example, that told me that f of 1 was 0. But then what about f of 2 squared? We can think of it as 2 times 2. So if I replace that, x with 2, y with 2. I'm here. I know that this is 1. So 1 plus 1 plus 1. So that's 3. And then the question is there a pattern as I go to higher powers? So f of 2 cubed would be, again, make x to be 2 square and y to be 2. And then f of 2 plus f of 2 squared plus f of 2. So this we have already computed. That's 3. F of 2 is 1. 3 plus 1. So that becomes 7. And then I do f of 2 to the 4. So this is, I actually did all this work because I think unless you clearly see a pattern, I don't jump to conclusions. So this would be f of 2 cubed, f of 2, 2 cubed plus f of 2. And then what you'll start to see that since f of 2 is 1, you're just doubling the previous value and adding 1. So I think that was the key insight. That means I can now jump to f of 2 to the 5, which would be f of 2 to the 4 plus 1, which means I just have to double this and add 1. That means f of 2 to the 6 is double 1. So 62 plus 1, 63. I hope I'm right on that. Yes. F of 2 to the 7 would be, you double this, 126 plus 1, 127. And then f of 2 to the 8 would be 254 plus 1, 255. And we can do the same thing for f of 5. So this would be f of 5 to the 4, because it will follow the same pattern, because f of 5 square would be f of 5 plus f of 5 plus f of 5. And note this is 1, just as in f of 2. So that becomes 3. So f of 5 to the 4th would be the same as f of 2 to the 4th, which was 15. So now we can go back and substitute that here to figure out f of 160,000, which would be 255. So I'm plugging it in here, times 15 plus 255, and then plus 15. And if you do this calculation using the calculator, you'll find this turns out to be 4,095, which is answer choice A. So, I mean, this is a difficult question. I think if I wasn't able to see pattern quickly, I would probably just skip this question or come back to it later. But it's, I think the key insight was to kind of rewrite it with the prime factorization and recognizing that how do we use this property? I think that was sort of is the clue for this question. So